Hello guys, it's me Teacher Hanji once again and welcome back to my channel. So we are done with quadratic equations and quadratic inequalities. So for this video, I will show you the models of quadratic functions. So for our objectives, we will define and express quadratic functions in the form function of x is equal to ax squared plus bx plus c, where a is not equal to 0. And we will model real-life situation using quadratic functions. So what is the difference of quadratic functions to quadratic equations? So when we say quadratic equations, we are using an equal sign. But in quadratic functions, we have here two variables, the x and the function of x. So other than that, quadratic function is defined as f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. F of x is also equal to y, so we can also have y is equal to ax squared plus bx plus c. The graph of quadratic function is parabola. So let us tell whether the following equations defined as linear or quadratic functions. Let us have number 1. Y is equal to 2x squared minus 2x plus 4. Yes, it is a quadratic function since it is in the form y is equal to ax squared plus bx plus c. Number 2, 4x is equal to x squared plus 4 minus y. It is also a quadratic function. It can be transformed into y is equal to x squared minus 4x plus 4 using addition property of equality. Next, y is equal to 3x plus 4. Yes, it is not quadratic function but a linear function. So why? Because it is in the form y is equal to mx plus v. Number 4, y is equal to 3x squared. Yes, it's still a quadratic function. It is in the form y is equal to ax squared plus bx plus c. Only that b is equal to 0 and c is equal to 0. Number 5, y minus x plus 5 is equal to square of x minus 2. Yes, it is a quadratic function. We can transform it into its quadratic form. But first, you need to use the FOIL method to the left side. So you have y minus x plus 5 is equal to x squared minus 4x plus 4. Using addition property of equality and combining the like terms, you have y is equal to x squared minus 4x plus x plus 4 minus 5. Simplifying that one, you will obtain the quadratic form y is equal to x squared minus 3x minus 1. Last one, 5 is equal to y minus 2x. Yes, it is not a quadratic function but a linear function. So y, you can rewrite it into y is equal to 2x plus 5. Yet, this one satisfies the condition of linear function, which is y should be equal to mx plus b. So this time, let us move on with the graph. Let us identify if the graph presented is a quadratic function or not. So remember that the graph of a quadratic function is a parabola. So let us see whether the given graph is a parabola or not. Number 1. Yes, it is a quadratic function since the graph is a parabola that opens upward. Let us have the second one. Okay, it is not a quadratic function, but that graph is a graph of a linear functions. Let us have the third one. Yes, it is a quadratic function. The graph is a parabola that opens downward. Let us have the last one. Yes, it is not a quadratic function. This time, let us model some real-life problem involving quadratic functions. So what are some examples of quadratic functions in real-life situation? First, the graph of throwing a ball at height h for a given time t defined by the function h is equal to 3 plus 14t minus 5t squared. The highest degree of the variable is 2, and the equation can be formed into h is equal to negative 5t squared plus 14t plus 3. The graph also shows a parabola. Thus, throwing a ball represents quadratic functions. Let us have a second one. The graph of a bike company's profit P gained at a given cost C, represented by the function P is equal to negative 200C squared plus 92,000C minus 8,400,000. The highest degree of the variable is 2. The graph also shows a parabola. Thus, the situation represents quadratic functions. Let us have the last one. If you drop a baseball off the roof of a 200-feet building, its height in feet can be modeled as h of t is equal to negative 16t squared plus 200, where h is the initial height and t is time in seconds. In the given functions, h of t is equal to negative 16t squared plus 200. The highest degree of the variable is 2, where a is equal to negative 16, b is equal to 0, and c is equal to 200. Thus, dropping off a ball from the roof represents quadratic functions. So in general, quadratic functions is written in the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Or it can also be written as y is equal to ax squared plus bx plus c. So the graph of quadratic function is parabola. So that's all for our video for today. You're doing a good job. Thank you for watching. See you again in my next video. Bye!